Hello viewers, today we're going to discuss about how to make a good dataset in order to use it after on R or Python. The basic first thing you need to know is that you need to spend the less time possible on Excel, okay? Or on any spreadsheet you use. Because the more time you will spend on Excel, the more you can make mistakes. We don't want to make a lot of copy-paste, okay? We just want to have a simple, pure, rectangular spreadsheet, okay? That we will after that incorporate on R or Python. So basically, we're just gonna look at how we can make those spreadsheets to be the most simple possible. And after that, I'm gonna show some example of what you can do with those spreadsheets once you are in R. We're gonna start with possibly one of the worst examples I got from a collaborator. Here we have an Excel spreadsheet with multiple sheets where you can find the bacteria that have been dosed for using a qPCR. So for each bacteria or each primer set, I get another sheet, and I get around 30 sheets for that. This is the worst thing to do. Never do that. Mostly because you will lose so much time doing your experiments after that, because you will have to make a lot of copy-paste. And if you just look at this, I've got multiple blanks and spaces here, okay? I have a beginning of analysis here, and it's going on and on for each sheet. What we need is a single dataset with my mouse number here being continuous and the cities, and that's all. We only need that, okay? And if there is one experiment and another extra, you just have to add a column, okay? We want only a single dataset. Another bad example is this. We are almost there, but we have here a title and another title for the columns that is shared for all of these columns, okay? And we have spaces here. If you want to try to import this on R or Python, you can't understand what you have here. And we will see after that what it does when we are trying to import it on R. Once more, here, I'm going to zoom it a little bit. We have a title that is shared for multiple columns. But we are almost there. We want to lose the spaces here, but we are almost there. Why we don't want spaces on our spreadsheet? Because when we will try to import this on R, this will be filled with NAs, okay? And R or Python or any bioinformatic tools will ask two things: a row name vector and a column name vector, okay? So R works with a vector for column names and a vector for the rows, okay? If you have this that is shared for all the columns, it will do a mess, a very big mess. And we will see that we will have more problems with this. What we want is something like this, okay? So I have a vector in columns and a vector in row. I don't have any spaces, okay? If I have spaces, it will be filled with NAs, because maybe if I have a value missing and I put it like this, I will have NA here, okay? But this is because the value is missing, not because I left blank or spaces. This is a good example of what we want. So for this project, I had to copy paste from this to this, okay? And I did the same for another set. This is exactly what we want. We want the metadata like this, okay? For each mice, I have my treatment group and the donor from which it came, because it was a fecal transfer. And here I have my parameters, okay? Please, when you are using parameters as column names, you need to get rid of spaces. It's the best practice to do is have no spaces, because the spaces are a separator, okay? So we want to have something like this. You also want to lose the slash, because this one would... Okay, so we are done for the Excel part, for the spreadsheet. We saw what you should do or not do. And now we are going to jump to R and import our different spreadsheets, so the bad ones and the good one. Okay, now we are in R Studio, okay? So look at my middle panel. I just took the path to my XLSX, okay? And I will use the package read Excel to read my Excel, okay? So here it's a XLSX, so this. I'm trying to get the first sheet that we saw before. And as you can see, we have a lot of troubles because we have nothing that is good here. We have no column names, we have one here, and we have NAs everywhere. You see, here we have control, here we have some numbers. And the worst thing here is all my columns and all my values are transformed from numeric, which is what they should be, to character, as you can see here. And if I'm asking, is numeric my XLSX 1, and I use, for example, this one, it will say no, because it is transformed as a character because of our troubles with the column names. Now I want to see if I did my work correctly when I use the copy-paste and I do the translation as I showed before. And here, effectively, we have a correct dataset. We have here columns with character, which are character, of course. Here also, and here also. Okay, this is exactly what I want because these are my metadata. And here I have all my values, my numerics values, okay? So this is what we want to get, not this, okay? For that I use red XLSX, okay? And you need to give the sheet that you have. If you have a CSV, it's that simple. You give the function read CSV and another path, for example, path 2 if I have some. But here I don't have. Okay. Now this is exactly the type of data that I want to make, for example, a heat map of or a PCA or a PCY, whatever you want. Okay. You can do ggplot with this, you can do whatever you want. The second thing that you can do with this kind of datasets is going from a wide dataset like this to a long dataset. What does this mean? This means that rather than have here 30 parameters as columns, I will only have one column for the numeric values and one new column with all of the parameters. So basically, what it will do is use this TUDCA by last name, make 66 times TUDCA, and I will have my values here as a new column that we can call value, for example. And for each parameter, I will have 66 new rows. So let's do this. We will use the tidyr package from the tidyverse suite. These packages are very excellent to work with. They are a little bit hard to take on at the beginning, but when you got the hang of it, it's very, very cool package. So what I'm gonna use? I'm gonna use my object, XLSX2, and I will give it to the function pivot longer, which is the new version of the gather function. You can still use gather, but pivot longer is like you want, but I think it's a little bit more easy to use than gather. We'll give the data. Here is the data. So if you are not using the pipe sign, you will use this XLSX/2. And if you just do that, you will end up with this. Okay, so I'm just gonna erase this and put it as a TMP object. control N3, and what I get from this to this, so I will put this one here so we can see both. So what happened? I still get my 3 first columns because I just asked from the 4th to the 33rd. Okay? And all my biases are now on this column that I called bias. What did happen? Here, for the mice, I will have 33 times the 906 mice, okay? And for the mice, I have each value of my biases. So I have the name of my biases, and here I get my value of my biases, okay? And it's the same, and so on for every mice, okay? Why do this? Because from what you want to do with your values, with your data, you will have to jump rather on the wide version, this one, or the long version, this one. If I want, for example, do a ggplot with a bias for each panel of for the groups on each panel, I can just use those 5 columns to make this. So if I'm doing a ggplot, okay, with the object MP, and I use AES, I want my group as X and value as Y. Plus, I don't know, a gmbox plot, okay. This is what I have, okay. These have no meaning. But if I'm using facet grid, for example, and I want to use the biased column, I will end up with, it's a bit long, but I will end up with this kind of plot. I will have a panel for each biased for the 3 groups, okay? But if I want to do a heat map, for example, a heat map, I want this kind of dataset. So for example, I will use XLSX2. Okay, just remember to remove the first 3 columns and put it as a matrix. Sorry, as matrix. Okay, and I have my heat map here. Okay, this is basically the same thing for a PCA or other multi-parametric analysis. If you want to do only a ggplot per bias and have the values, you can do multiple ggplots. But if you want, for example, to have a large look at your data, I encourage you to do this using this one. And as you can see, I just needed 1 line of code to perform this and to go from this to this. And I can do with 1 line the exact opposite, okay? If I wanted to do this on Excel or on Office or on any of other software, it would take me ages and a lot of mistakes, etc., etc., because I have a lot of row now, okay? So if you want to manipulate your data, please do it in R or Python. Don't do it on your Excel or any software that you use for that, okay? Because if I want to do a sum, a mean, or anything else, I can do it on R with just 1 line, okay? And store it and export it if I want later on, okay? Don't do it in Excel. If I want to have the mean of this one, I will just make mean, okay? XLSX2. I have my mean, okay? I can even do even nicer summary. Okay, and I have everything I want here on my console. And I can store it, I can do whatever I want because I'm in R. Okay, you can do the same thing on Python. Don't do it on Excel. Okay, let's summarize what we got here. We want a simple dataset that will give all your patients and all your parameters that you got. Okay, if you have 2 experiments, for example, flow cytometry and qPCR, you can do 2 separate datasets that you can merge later on R or Python. But you don't want especially to do 1 sheet for each patient or for each parameters. You just make a dataset with your patients like this and your parameters like this. You can translate it the other way around if you want, but personally I prefer to have it like this, okay? After that, you can merge if you have two different sets, or you can pivot your data frame if you want in R. You want to avoid spaces and blanks in your dataset because it will be filled with NAs. You also want to remove and to make sure that you have no spaces before or after your column names. If you use, for example, sample name and you put a space after that, it will not be the same as sample name without the spaces. Okay, the space is a common character for in informatic and bioinformatic, as every separator or character. If you want to make a complex column name, use underscore or dashes. Okay. You also want to avoid slash because the slash is reserved for path file. Okay. One little thing left. If you are using another version than the American Excel, you should use the American Excel because, for example, for the French version, the CSVs will be separated with semicolons instead of comma. This can give you some problems after that. And one thing that I had a lot of troubles when I begin with R is how you separate the values, the decimal values. Is it with a dot or with a comma? So be careful. Usually it's with a dot, but sometimes software can use the comma, and you will end up in R not with numeric values but with characters because it doesn't understand that the comma is for the decimal values. So be careful with that. You can have a lot of trouble in your early stages of R. We have reached the end of this video, so thank you so much for watching. If you have any comments or any questions, feel free to ask in the comments. If you want to go deeper or further on R or Python, just make sure to use the forums, the tutorials, because there is a lot of community around R, Python, or even Panda if you want. So if you have any trouble, you can find someone that went through these troubles. And you can also find help on forums like Stack Overflow. Anyway, thank you so much for watching and see you next time. Bye bye.